Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India Aakash Test Series JEE Advanced 2020 Test 3A Paper 1 Code A and B. So let's start with the first section, students. So this section contains 5 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 21. So question number 21, it says the correct statements regarding the complex CrCl3OH whole twice NO3 minus ion is R. So looking at the options, the examiner seems to be interested in the geometrical isomers, the stereoisomers, and also the magnetic moment of the complex. So students, we can first start with the magnetic moment of the complex. So for that we need the oxidation state of the central metal ion. So if we look at the complex given to us, we can see that chromium is present in a state of +3. Okay, so if you talk about chromium 0, so chromium 0 has S1D5 configuration. So if we talk about chromium +3, so it is going to have a D3 configuration. Okay, so irrespective of the strength of the ligand, this will generally form inner orbital complexes. So the hybridization will be D2sp3 and the number of unpaired electrons is going to be 3. So if n equal to 3, then the value of mu shall come out to be equal to √15, and this is equal to 3.87 Bohr magnetons. Okay students, so the fourth statement is correct. Now if we talk about the geometrical and the stereoisomers of this complex, students, so we can have cases in which all the 3 chlorine are cis with respect to each other. Okay, so the other 3 positions are also cis with respect to each other then. So it does not matter which ligand we place where, they're going to have identical configurations. Okay, so we have this case when all the chlorine are in cis position. We can now move on ahead to cases where the chlorine atoms are present in a trans position. Okay, so we can have 2 chlorine at the trans position and we can have the other chlorine anywhere. Okay, now if you look at the ligands present, students, now we can have 2 cases in which the OH are cis with respect to each other and the third position is occupied by the nitrate ion. And if we talk about the other case, so here we had OH cis, now we can have OH trans. Okay, but the third position is occupied by the nitrate ion. Okay, we're not dealing with the charge on the complexes. Okay, so these 3 possible geometrical isomers exist for this complex, students. And if you talk about the optical activity, so the trans compounds have a trans pair and they will be optically inactive. They have a sigma. If you look at this cis complex now, in the cis complex, although there is no trans pair, but then we'll have a plane which is passing through this chromium NO3 and Cl, which will divide this complex symmetrically. Okay, so this also has a sigma. So all 3 of these stereoisomers, they have a plane of symmetry and then they're not going to be optically active. So enantiomeric pairs for them will not exist. Okay, so if you look at option A now, it has only one optically active stereoisomer. This is incorrect, students. There is no optically active stereoisomer possible for this complex. If you look at option B now, it has 3 geometrical isomers. This is correct, students. This complex has 3 geometrical isomers as we have just drawn. If you look at the C statement now, there are a total of 4 stereoisomers. This is incorrect, students. There are only 3 stereoisomers possible in total. Okay, so for this question, students, we have to mark the correct answer as option B and option D. Okay, let us look at the next question now. Question number 22. Which of the following change occur when the solution containing Mn2 plus and Cr3 plus ions is heated with NaOH and H2O2? Okay, students, so if we talk about H2O2 in OH minus, it acts as a strong oxidizing agent as well as a reducing agent, but in this case it will act as oxidizing agent. It will oxidize Mn+2 to Mn+4. Okay, so the Mn+4 will be precipitated in the form of MnOH twice, which is also called as the hydrated manganese dioxide. Okay, and if we talk about the chromium +3 ions, the chromium +3 ions will be oxidized to Cr+6 and they will be present in the form of the chromate ions. which is the CrO4 2 minus ion, students. Okay, so if you look at the options which are given to us, so the first option, it says hydrated manganese dioxide and Na2Cr2O7 are formed. This is incorrect, students. Na2Cr2O7 does not exist in the basic medium. Okay, so it will convert into the chromate. If you look at the second option, we have Mn in the state of +2 and Cr in the state of +3. So there is no redox reaction happening, so this is also not possible. If you talk about the third option now, we have MnO OH whole twice and Na2CrO4 which are formed. This is correct, students. Hydrated manganese dioxide and chromate ions will be formed as we had seen before. And if you look at the last option now, we have the formation of Na2MnO4 and CrOH whole thrice. So this is also not correct, students. Let us look at question number 23 now, students. Which of the following compounds give different product by SN1 and SN2 mechanism? So the examiner has mentioned to consider the stereoisomers as different products. Okay. So if you look at the first option now, so if you talk about the SN2 reaction, so the first compound is going to form this compound by the SN2 reaction. So the OH minus will attack from the backside of I minus, and we're going to have the OH minus or the OH group present at the dash position. Okay, so this is by SN2 where there is inversion. Now if you talk about the SN1 reaction, students, in the SN1 reaction there will be first formation of a carbocation over here, which will rearrange to give us a tertiary carbocation. Okay, and now the OH minus can add here. So we have seen that the first compound, it forms different products when reacted with NaOH via the SN1 or the SN2 mechanism. So A is going to be an answer. If you look at the second option now, in the second option, again, as we had seen before, the I minus is present in the dash position. So the OH minus will be present in the wedge position when we talk of SN2. And if we talk about SN1, so during SN1 there will be racemization happening. So we're going to have OH and we're going to have both the R as well as S pairs. Okay. So SN2 reaction gives only one product, whereas the SN1 reaction gives a racemic mixture. So this is also going to give different products. Let's look at option third now. In the third option, the carbon atom is not chiral. So this is not chiral. So it does not matter which way OH minus attaches. It is going to be the same compound. So they are the same if you talk about SN1 as well as SN2. And if you look at the last option now, as we had seen before, in the last option also, via SN2 there will be a inversion of configuration. So we're going to have the formation of this via SN2. And if you talk about SN1, we're going to obtain a pair of diastereomers. So we're going to have a mixture of diastereomers in this case. Okay. So the reaction given in option D is also going to produce different products with respect to SN1 and SN2 reaction. So for question number 23, students, we have to mark the correct answer as option A, option B and option D. Let us look at the next question now. Question number 24. Identify the correct statements about the given compound. So a structure or a diagram has been given to us. Let us start with the option, students. So the A option, it says it represents dimeric and hydrated copper 2 acetate, which is Cu2 tetraacetate and 2H2O. So if you look at the compound, students, we can clearly see that this representation or the formula given to us is correct, students. So it is indeed dimeric and hydrated copper 2 acetate. Okay. If you look at the B option now, its structure is roughly octahedral with each Cu atom coordinately bonded to 5 oxygen atoms and the 6th position is occupied by the other Cu atom. So this seems to be correct, students. It can have an octahedral geometry as it is evident from the diagram. So these are the 4 valencies in the plane and the 5th position is occupied by OH2, whereas the 6th position will be occupied by the Cu. Although there is no bond between Cu and Cu, so it can be assumed to be a pseudo octahedral structure. Okay. Similarly for the bottom Cu as well, it is a symmetric structure and this also has a octahedral geometry around it. Okay. So the second statement is also correct, students. If you talk about the third option now, it has one Cu-Cu sigma bond and is diamagnetic. So this is incorrect, students. There is no Cu-Cu sigma bond as it is shown in the diagram also. So this is incorrect. And if we talk about the magnetic nature, so we have copper present in a state of +2. So it has a D9 configuration. So D9 configuration is going to be paramagnetic. Okay. So it has a paramagnetic nature. So the C statement is incorrect, students. If you look at the last option now, the electronic configuration of Cu+2 is 3d9 and the complex is paramagnetic. This is also correct, students. So if you look at the options which are given to us, we can clearly see that we have to mark the correct answer to this question is option A, option B and option D. Let us look at the next question now. Question number 25. Which of the following statements are correct with respect to ferrous ions and cupric ions present in separate solutions? So the first option, it says both the metal ions have 4 unpaired electrons each. So we can have Fe2 plus. So Fe0 has S2D6 configuration. So Fe plus 2 is going to have a D6 configuration. So the D6 configuration, there are 4 unpaired electrons. If you talk about Cu2 plus, so Cu2 plus has a D9 configuration and it has only 1 unpaired electron. Okay. So the first statement is incorrect, students. The Cu2 plus does not have 4 unpaired electrons. If you talk about the second option now, both react with NaOH. This is correct, students. Fe2 plus, they react with OH minus to give us FeOH whole twice, which is a dirty green precipitate. And if you talk about Cu2 plus, they also react with NaOH to form CuOH whole twice, which is a bluish white precipitate. Okay, students. So the B statement is correct, students. If you talk about the C statement now, Cu2 plus ions give bluish white precipitate and Fe2 plus ions give dirty green precipitate of this. So this is also correct, students. CuOH whole twice is bluish white and FeOH whole twice is dirty green, as correctly mentioned in the option. Okay. If you look at the D statement now, Cu2 plus ions give chocolate brown precipitate, whereas Fe2 plus ions give red PPT. So this is incorrect, students. Fe2 plus ions do not give a red PPT with K4FeCN6. Okay. So students, for this question we have to mark the correct answer as option B and option C.